Good morning, all of you. This is Dr. Subramanian Rao, Professor of EC Department, Sasi Institute of Technology and Engineering, Tadepalligudem. Today, I am going to give brief introduction of Signals and Systems subject, which is there in second year BTech level for EC students, and it is as per JNTUK R20 regulations. In my 20 years of teaching experience, I taught several times signals and systems, digital signal processing, and digital image processing. Coming to the origin of signal processing, basically it came from engineering mathematics. Coming to the signals and system, there is one important classification of signals, that is deterministic and random. If the signal is deterministic, it is represented properly with a mathematical equation that leads to one subject, that is signals and systems. On the other hand, random signals cannot be represented with mathematical equations because of uncertainty. So we go for probabilistic way that leads to another subject, probability theory and stochastic process. So signals and systems and probability theory are two parallel subjects that students are going to study. Next, the signals and systems is extended to digital signal processing, where we discarded continuous signal processing completely, and we concentrate more on digital signal processing. And here we are dealing with one-dimensional signals. If the student want to extend his knowledge in signal processing to two-dimensional signals, nothing but images, they are going to study digital image processing in the third or fourth year level as an elective subject. The textbooks or reference books that I prefer for this subject are Signals and Systems by Oppenheim and Nawab. It is very famous book. Most of the GATE aspirants also concentrate on this book. Especially the chapter end problems are very important for GATE related exams. Another book where some of the topics are good is Signal Systems and Communications by B.P. Lathi. Especially students will prefer this book for Fourier series, signal analysis, analogy between vectors and signals, and LTI systems. Students generally prefer this textbook. Another textbook which covers most of the topics is Signals and Systems by Oppenheim. Last but not least, the Signals and Systems by A. Anand Kumar. Here the theoretical topics are explained with very easy language and most of the problems are solved. So students can also prefer this textbook. Coming to the course objectives, upon the completion of the course, the student is able to study various signals and systems, both in continuous time and discrete time case, and analyze spectral characteristics of signals, which is nothing but frequency domain representation of signals. Here we cover Fourier series and Fourier transform. Next, understand the LTI characteristics of the system, which highlights linearity and time invariance properties of the systems. Next, we introduce the concept of sampling process, which is very important in the conversion from analog to digital signals. And finally, know various transform techniques to analyze signals and systems, which covers Laplace transform and jet transform, which is very useful for the analysis of signals and systems in the complex stage. Coming to the course outcomes, the first CO is differentiate various classifications of signals and systems, which is dealt under BTL level 2, that is understand. Here we study classification of signals, classification of systems, various operations on signals, analogy between vectors and signals. Coming to the second CO, construct frequency domain representation of signals using Fourier concepts. Here we concentrate on Fourier series and Fourier transform. As we know, Fourier series is for representation of periodic signals, whereas Fourier transform is for non-periodic signals or finite duration signals. Coming to the third CO, apply systems and determine response of LTI systems, which is also dealt under BTL level 3, that is apply. And the fourth CO is interpret the sampling process and various types of sampling techniques, which is dealt under BTL2, understand. Finally, we are going to extend the transforms what we have discussed in the second CO. Those are apply Laplace and jet transforms to analyze signals and systems both in continuous time and discrete time. This is also dealt under BTL3, apply. Coming to the outcome-based education, there are, as we know, there are 12 program outcomes where all courses covers under these 12 program outcomes, and we have chosen for signals and systems course 4 POs. The first PO is engineering knowledge. Almost all course outcomes are dealt under engineering knowledge. And second PO is problem analysis. Here CO1, CO2 and CO5 are going to be considered under problem analysis. Next PO is PO5, which is usage of modern tools. For easy understanding of the students, some of the topics we are going to show in simulation software like MATLAB. So CO1 to CO5 all can be considered under MATLAB software. Finally, PO6 Engineer and Society, we mapped CO4 for this CO because in most of the today's digital technology, sampling is one of the important steps that every engineer has to learn, and there are several societal applications related to this CO. And for effective teaching and learning of this course, we have adapted some innovative teaching methodologies for this course, signals and systems. Some of these methodologies are video synthesis, animation, problem-based learning, quiz, program-based learning, and flipped classes. Under video synthesis, we show some of the topic-related videos, and we pose some questions on the students, and we clarify their doubts. And some of the topics where students feel tough, we can explain them using an animation, especially for evaluation of Fourier series, we can show with an animation. Next, almost all course outcomes can be considered under problem-based learning. Immediately after the teaching of a particular topic, we can solve related problems, and where and when required, we conduct some quizzes for the benefit of the students. And also for some topics, we can deal with MATLAB software, which comes under program-based learning. Finally, flipped classes. Flipped class is completely different, where teacher will not teach anything. Well in advance, some topics are given to the students. They come prepared for the next day, and we raise some healthy interaction among students on the given topic, and finally we clarify their doubts and we conclude. Next, coming to the introduction of the course, why student has to learn signals and systems subject. Before going to that, first we need to justify 3 things here. What is a signal, what is a system, and what is signal processing. Coming to the signal is a physical quantity that varies with respect to any one of the independent variable. In the entire course, we considered the time is the independent variable. Some of the examples are speech signal, biomedical signals, video and image, temperature, speed of vehicles, like that. N number of examples we can take. Let us see some of the examples where it is a random signal and it is an image, and earlier one is one-dimensional, image is a two-dimensional, and similarly we can consider deterministic signals like this, S of t equal to 5 into t. Here t is the independent variable and S of t is the dependent variable which we take along y-axis. where the independent variable time is taken along x-axis. Second one, coming to the system. System is a physical device that performs some operation on the signal. This is the block that shows system and the relation between input signal and output signals. We can take a number of examples. The famous examples are public addressing system, digital computer and mobile phone. Here, system performs some operation on the input signal and gives a modified signal as output signal. Next, coming to the signal processing. Processing of a signal using a system. As signal carries some useful information, signal processing is for extracting, enhancing, storing or transmitting some useful information. We can take a best example of a signal processing of a system. It is a filter. Here we have given an image, cameraman image, and which is blur. So what is our task here? Here the operation we are going to consider is removing of blur. If this blur image is applied to a filter, we get a clean image as output image. So here filter is a system, blur image is the input signal, clean image is the output signal, and removing of blur is the operation performed by the system. With this small introduction of the course, I am going to stop at this stage. I hope you may like this small brief introduction. Thank you one and all for patient listening.